Hey, look at this. 5 people are with us. That's exciting. Good morning, all my Zoom people. Okay, so y'all have done your attendance question. Zoom people, do your attendance question. We are doing lesson 5-2 today, but I wanted to draw your attention to the fact that you guys do have a quiz tomorrow. Let me go back to our module. And that's kind of what's cool about your modules is you can kind of see what I have planned for this week. So if you look at Tuesday, you have your geometry quiz 2. That quiz is over lessons 4 and 5. Okay, so we're going to finish up 5 today. Lesson 4 was all about the midpoint. Not the midpoint, I'm sorry, the mid-segment, your segment addition postulate, and then finding that midpoint of that, which is just really cutting it in half. And then also your angle addition postulate. Okay, so that was lesson 4. And then lesson 5, the first part was your distance formula. And then we're going to do the second part today. Okay, so I told y'all we'd be swapping off. A day, you were in class last quiz, so B day is going to be in class for this quiz. So you'll be taking yours at home. I believe that your quiz is available until the end of the school day. I don't think that you have until midnight to do your quiz. It's still the end of the school day, so 3:45 is when I've cut that off. So make sure that when you get up tomorrow and you get going that you take that quiz before the end of the day. Don't wait until 6 p.m. to do it. It's due before 3:45 because you need to take it during school hours, okay? You don't have to take it second hour, but just before the end of the school day, okay? Okay, so this has got your notes. It says we're going to be on page 56 through 58. I didn't put a homework key up here. Oh, we already did that. Your Friday was Delta Math, right? That's what y'all did on Friday? Okay, good, cool. All right, so then let's just jump right into this lesson. Get going. All right, so page 56, this lesson this lesson is about the midpoint of the coordinate plane, okay? So we were able to find the midpoint of just a segment by just averaging it together, which meant we added the endpoint plus the endpoint, and then we divided by 2. Well, now we're going to be doing this for a coordinate plane, which means we're all going to have a horizontal axis to deal with as well as a vertical axis. So we're dealing with a 2-dimensional situation instead of a 1. Okay, so our learning targets here say that we are going to use inductive reasoning to determine the midpoint formula, which we've already actually talked about, okay? When we did that geometry basics at the beginning of our school year, we talked about the midpoint formula, but we'll see how that goes today. And then we're also going to use the midpoint formula to find coordinates of the midpoint of a segment on a coordinate plane, okay? All right, so it says before number 1, in the previous activity, you defined midpoint as the point on a segment that divides it into 2 congruent segments. Following the steps below to explore the concept of midpoint on a coordinate plane. In the table below, write the coordinates of the endpoints of each segment shown on the coordinate plane. All right, so we can do this together pretty quickly. Actually, I need to be able to see that graph. All right, so if we look at the first one, segment AB, okay, what is the endpoint A? Where is it located? 2, 2, right? Okay, and then segment B is located at 2, 6. Very good. Okay, we're just going to do the endpoints, and then in a second we'll talk about the midpoints. Okay, if we look at CD, segment CD, where's C located? 5, 7. And then where's D located? 11, 7. Okay, E. Where's E located? 4, 1. And where is F located? 6, 5. Okay, where's G located? 8, 4. And H is located at. Now, if we're going to find the midpoints, okay, what we're going to do right here is we are going to determine where the middle would be. So if we look at segment AB, that one's very easy because it's flat, okay, or not flat, it's vertical. So it's like we could go one block this way, one block that way, one block this way, one block that way, and so you know that's going to be your midpoint. So where's the midpoint of that one located? At 2, 4. Okay, so located at 2, 4. Now look at your endpoints of AB. What do you notice about the X's? They're all 2s. So we've got a 2 here, a 2 here, a 2 here. Why is that? That's right. They're all on that same vertical line, so they're all going to be the same. Now look at your Y's. This one's at 2, this one's at 6, and this one's at 4. So how did they get that? Or how would you get it if you didn't have the graph? Like think about, okay, 6 minus 2 does give you 4, okay? So that might be a method, but if we were dealing with just a single number line and we had 2 here and 6 there, what could we do mathematically to get that midpoint of 4? Do you remember? That's going to give us the distance, and then we could find the distance and divide that in 2, but remember we could average it, okay? You could take your endpoint plus your endpoint and then divide by 2. So what's 2 plus 6? 8. 8 divided by 2 gives you 4. So when you're looking at a single X or a single Y, then you can view it just like it's a number line, okay? It's kind of like you can take it out of the coordinate plane and look at the X's in isolation. Just look at the X's by themselves or just look at the Y's by themselves. Okay, so let's look at CD. CD is horizontal, so it again is very easy for us just to, you know, one this way, one that way, until we can get to the middle, which is located at 8, 7. Okay, same thing. What's 5 plus 11? What's half of 16? That's where we get the 8. What's 7 plus 7? What's 14 divided by 2? So that's where we get our 7. Okay, so we're able to see that using that individual formula and just look at the X's, just look at the Y's. Okay, now if we look at E and F, okay, if we weren't like figuring this out together, what you could do is you could look at it and think about rise over run, okay? And so if we did that, I can have another good point here, and I can prove that that's the midpoint because if I rise to run 1, rise to run 1, that's the exact same movement, okay? So knowing that I'm rising to running 1 each time is telling me that that is a good point, and it's also going to be the midpoint. What you can't do is like count diagonally. There's no way for you to count diagonally. That's not a thing. So that's why it's important for us to kind of have that formula, because being able to locate the points of a diagonal can be more challenging. Is that right? Is that at 5, 5? Yeah? 5, 3? Okay, cool. 5, 3. Thank you. Now, let's look at GH, and let's do it with just the X's. So what's 8 plus 14? 22. So what's 22 divided by 2? 11. What's 4 plus 0? What's 4 divided by 2? So would it look appropriate to have our midpoint at 11, 2? Yeah. And you can even check with the slopes, like I was saying. From H, we could rise 2, run 3. Rise 2, run 3. So you can see it has the same exact movement. So that's going to tell us that is definitely our midpoint. Okay. Now, let's go answer these questions in our notes. Number 2, use the x-coordinates in Table 1. Compare the x's and the endpoints of each segment of the x-coordinate of the midpoint of the segment. Describe the pattern. Okay, well, that's what we've already done. Let's skip to number 3. Number 3, they're ready for our equation, because we've already done 1 and 2 in our discussion. All right, so if we look at number 3, it says use the patterns you described in items 2 to write the formula for the coordinates of the midpoint M of a line segment with endpoints x1, y1, x2, y2. Okay, so when we were finding these, we were taking the x's, no matter what numbers they were, and what were we doing with those x's? Adding them together and then doing what? So that's how you're going to find the x. Then put you a big comma in the middle, because what we're looking for is a coordinate pair. So this is going to give us our x coordinate. How are we going to get the y coordinate? That's right. And does it really matter if you put y1 first or x, does it matter which one comes first? No, because the addition property is commutative. You can do it either way, and so you're good to swap them around, but that's going to be our midpoint formula. That's the formula that you will use to find the midpoint of any points on a coordinate plane, which is very helpful when they give you large coordinates, or if they give you negative coordinates. Just kind of makes your life a little bit more simple. You don't want to have to go and plot everything out every single time to be able to figure out your answer, okay? All right, so if we look at what number 4 says, number 4 says, look back at the chart on item 1 to verify the formula you wrote. Use the formula to find the coordinates of the midpoint M of AC with endpoints at 1, 4, and 11, 10. What would you conclude about the segments AM and the MC? Okay, so the first thing they're wanting us to do is find that midpoint. So we can use our formula that we just wrote and say 1 plus 11 divided by 2 and 4 plus 10 divided by 2. All I did was take the x and add it together, and then the y and add it together. So what is 1 plus 11? 12 divided by 2 is, okay. Then we have 4 plus 10, which gives us 14 divided by 2 is 7. So they're wanting us to determine the segments. What do we know about the segments AM and MC? Okay, let me go and look at it on this page. So we're putting it at, is it using this? I'm confused. It's not using this? It's just some random points? Okay, that's fine. Well, what we're dealing with here is the fact that we've got this segment that's from 1, 4, which 1, 4 would be here. We could call that A. And then we've got C, which is at 11, 10. Now, I'm not going to get this exact, but it would be like, we'll say somewhere over here. Okay, so this is just a sketch for us to look at. Then we're going to have M right in the middle. So what do we know about this segment in comparison with this segment? They are the same length, which means that they are congruent. So we're going to say AM, segment AM, is congruent to segment MC. And you know that they are congruent because you have identified the midpoint. That tells us that they are going to be congruent. Number 5 says, how could you check to see if your answer is reasonable? Okay, if I was like, now prove it to me, how do you know that they are congruent? What would allow us to prove that they are congruent? The what? Okay, yeah. What if you didn't want to graph it? Using the distance formula. So if you had to prove that they are congruent, then you would need to prove that their lengths are the same. You would do that with the distance formula. Number 6 says, suppose a segment on the coordinate plane is vertical. Can you use the midpoint formula to find the coordinates of the midpoint? We saw that on the very first page. Remember, our vertical one was what? AB? Could we still use the midpoint formula for that? Yeah. Just when you add them together, what was it? Like 3 plus 3? That gives you 6. You divide by 2. Well, it's still going to be at 3. Okay, so you can definitely still use that, even if they're vertical. So we'll say yes. Number 7 says the midpoint M of segment ST has the coordinates of 3, 6. Point S has coordinates of 1, 2. Determine the coordinates of T. Y'all, this is how ACT loves to ask this question. They're going to give you the midpoint and one of the other points and ask you to find the missing endpoint. So for me, I like to think about this in terms of algebra, okay? So I know that I'm going to have x plus x divided by 2 equals the x of the midpoint. Okay, this is my midpoint. So what I already know is that the x of the midpoint is 3. So I know it's going to equal 3. Okay. I also know one of the x's. So I can have 1 plus x divided by 2 equals 3. So you can see I'm only focusing on the x's right now. I can't look at the y's. I just am focusing on the x's. I know one of my x's that are my endpoints, and I know one of the x's of the midpoint. Then you just solve this algebraically. How would I get rid of the dividing by 2? So I would multiply both sides by 2. That gives me 1 plus x equals 6. Then I'm going to subtract 1. So the x value of the other endpoint is at 5. That's just the x's. Now we need to repeat that process for just the y. I'm going to have a y plus y divided by 2 equals the y of the midpoint. So the y of the midpoint is 6. So it equals 6. One of the endpoints is 2. And then now you have an equation that you can solve. Same thing. How do you get rid of the dividing by 2? You multiply by 2. So you've got 2 plus y equals 12. Then we subtract the 2, so y equals 10. So the other endpoint is going to be 5, 10. And that is usually how the ACT asks, because it would be too simple, you know, just to give you 2 endpoints and say, find the midpoint. Anyone could do that. That's very simple. You just add them, and divide. But this makes you think outside of the box. It makes you think backwards. So that's why I'm setting up an algebraic expression. Now, that's not the only way to do this. If you wanted to, you could draw yourself a table. You could plot your endpoint, plot your midpoint, and then you could just repeat the slope. Okay, you could say, I go up however many, and I go over however many, and then you could repeat it. Up, over, and that would give you your other endpoint. So that's another option. If you wanted to draw it out, you could definitely do it that way. Okay? All right. Number 8 says the origin 0, 0 is the midpoint of a segment. What conclusions can be drawn about the coordinates of the endpoints of the segment? If 0, 0 is your midpoint, what do you know about the endpoints of your segment? The x, like if one of the x's is 2, what's the other x going to have to be to give you 0? -2, because they're going to add together, so they'd have to be opposites, because 2 plus -2 is 0. 0 divided by 2 gives you 0, okay? The y's, again, if one of the y's is 7, the other y has to be -7, because 7 plus -7 gives you 0. 0 divided by 2 is going to give you 0. So your x and your y's of the endpoints have to be opposite of one another, okay? So let me just say opposite x's, opposite y's. I'm finding if I don't write it on my notes, the students that are virtual won't write it either. So opposite x's, opposite y's. That's it. Oh my gosh. That's all there is to it. So that's all your notes for today. Easy, easy. You do have homework on page 58. I want you to do all of that, 9 through 14, for your homework today. When you're done, submit all of that, but you need to make sure your name is in each of your submissions, because what's happening is, like, my people that are in class are just texting the notes to their friends, and then their friends are not writing down the notes. They're just submitting your picture. Okay, so I'm getting some of the same file names. That's why that's happening. So make sure your name is on it. That way, if you do send it to your friend, they can't submit your picture, because you're going to end up getting in trouble too for submitting that or sending that to them, and y'all having the same codes or same file name. So make sure you're being on the up and up, you're doing your own work, you're submitting your own pictures. Okay? Virtual people, do y'all have any questions for me? Okie dokie, be ready for your quiz tomorrow.